wavelength absorbed by the anthocyanin depends on pH, but in nature it's normally found as purple.
Here's a simple schematic of what's going on in a dye solar cell. Instead of starting at the dye and the anode, where electrons are first excited off of the dye molecules into the circuit, let's look at the cathode and how electrons make their way back to the dye. This image at the top draws out exactly the ideal path of the electron. So if we start at the cathode, the conductive glass, you'll see the electron is transferred over to our electrolyte. Triiodide, by gaining 2 electrons, is reduced to 3 iodide anions. Then these anions diffuse over to the dye and replenish its emptied supply. So what we're trying to do at the cathode is efficiently transfer electrons from our conductive glass to the electrolyte.
When this gets photoexcited, it spits off an electron, and it will send it through the circuit, and it will come right back.
I believe what we've made so far is a suspension of titanium dioxide with acid, so that we can, quite unknown, what we want is a bunch of titanium dioxide particles on our glass, on the conductive side of the glass.
I got chose for this part of the experiment to do the sintering process. I chose to do it with a hot plate. You put the temperature to 450 degrees. The glass should be heated on a hot plate in a hood for 10 to 20 minutes. The surface will turn brown as the surfactant dries off to produce white greenish color. You then allow the glass to slowly cool, or you can put the glass slide in an oven broiler for 60 minutes, coated side up. Make sure the slides turn yellow and then white, and then let it cool at room temperature.
Out of this alternator, which Nick donated, comes out of a 99 Mazda Miata. It's rated for 70 amps at maximum, and its output voltage is 12 volts. We'll be hooking up to our bicycle apparatus, pedals, chain drive to this right here, which will be a belt drive to the alternator there. To figure out power, it's a very simple formula. Power equals voltage times the current. 840 watts maximum. Now I'd like to see the guy who could produce that. Good luck.
Who has good legs? This guy.
He gives a mechanical advantage. So if you have gears with few teeth, and you turn them up with a gear with many teeth, you get more rotation when you use it. This is what our setup could look like.
Oh wow.
Hello, and welcome to the wonderful world of diodes. The key function of an ideal diode is to control the direction of current flow. Current passing through a diode can only go in one direction. They're like the one-way valve of electronics.
It's just not quite as impressive when there's not 6 batteries connected. So in conclusion, what is the essential difference between a generator and a motor?
See, alright, the generator turns work into electricity, and the motor turns electricity into work. So if you spin this yourself, and see this passing from over the magnets to empty space, over the magnets to empty space causes the current. But if you apply the current, this will spin and do work for you. Alright.
Put some water in there, and it made a dye and water solution that would soak the titanium oxide light in, so it would coat that, and that's how the light cells are captured. They're captured by the dye. Actually, I have it.
So the light is captured by the dye on the top slide?
Yeah, let me show you.
Oh, good.
Yeah. So the light comes in and they do this little thing with the electrons, and the dye captures the light. Like that's their purpose. They can capture photons. So that's why we coated the dye.
Proof of concept. It works.
Right now, the generator is not connected. It's pretty easy to cut off. As soon as it's connected, we create electricity. Oh my earth to generate those electromagnetic fields we are using to light up this light bulb.
We can see the voltage we're getting out also. Whoa. I think you almost broke. So what is actually happening when you connect that?
Creating a current. It's magnetic field. It's very difficult to get it going.